Hello guys, and welcome to the new series. We're going to explore today how to build a T-Pod Honeypot on AWS. You might ask, what is Honeypot? So Honeypot is essentially, it's a decoy device that we can build and track all the threat actors, what kind of attacks are they using. There's numerous number of dashboards that we can explore from terms of what usernames they're trying to exploit, what passwords they're trying to exploit, what current vulnerabilities they're trying to exploit. So there's various possibilities for us to track what threat actors are doing, and essentially and do some further research. So we're going to deploy the most famous T-Pod. So if we just Google T-Pod Honeypot, it takes us essentially to the T-Pod that's built by Telecom, to their GitHub repository. So if we enter that address, as you can see, there is T-Pod all-in-one multi-honeypot platform. So essentially T-Pod has many different honeypots within the T-Pod platform. So as you can see, there is a disclaimer. There's obviously various technical concepts. So what kind of Docker images they deploy, how does the technical architecture work, what kind of services we can use, the type of user accounts. The important bit is here. So when we deploy, we need to understand obviously what kind of storage and RAM we're going to need, how we can run. So there is various ways we can run it. We can run on VirtualBox, we can run on VMware Fusion, as you can see, Intel and Apple Silicon UTMs, but we will try and deploy it in the cloud. There's also various here tables of required ports that we need to open, but I'll showcase that further. So as we can see, there is various installations. So we can do ISO based installation, we can download the ISO image, we can also do T-Pod installer through cloud deployment. So if you wanted to further your skills within how to do with Ansible deployment, Terraform deployment, how to start it and how to use it. But we're going to focus today deployment on virtual machine, because you can also deploy it on Docker containers as well, and you can build it and play around with it. But I'll just showcase the easiest way, how you can easiest deploy it, how you can run it, and I'll showcase how the T-Pod looks itself once it's up and running. So we will follow these installation guides. But what we need to do, so if we go to my Amazon EC2 dashboard, I'm not going to showcase today how to create a AWS account. That's pretty simple, guys. You can set up a AWS account, but essentially what you need to do is you need to go to your EC2 dashboard, and we're going to launch an instance. So we need to launch a new instance for this specific deployment. Also, one thing to note, it's very important that this requirements, so minimum requirements for the ISO image build, it needs to be built on Debian 11 host system, because some of the other ones that I've tried, they don't work. We need a minimum of 4 gigabytes of RAM and a minimum of 32 gigabytes of free storage and working internet connection. So that's the minimum requirements that we need. So if we go to our EC2 management, we're gonna launch an instance, and I'm gonna showcase how to do that. So what we need to do, we need to name an instance, so we can create whatever name we want. So I'm gonna name that Debian instance. So here we go, we have a different application and OS images, and that's the important part. We need to make sure we select the correct image. So we can search for Debian. And as you can see, if we look at just quick start AMIs, we get Debian 12, but that's not gonna work. So we need to go browse AWS Marketplace, and we need to select Debian 11. This is the most important part. So as you can see, this is free. Obviously, we can select this image, and obviously there's various options. So typical price is 39 cents per hour. So just bear in mind that obviously once you build it, obviously you're going to incur some costs with it. So, you know, you can run it for a day or so. That's going to cost you around, well, $8-7. So it's not going to be that costly, but it's quite an interesting project to have a play around and to have a look what kind of attacks are happening out there live in the wild. So once we select that, so what we need to do now, we need to select the instance type as well. So as you remember from here, we have to select a minimum of 4 gigabytes of RAM, 32 gigabytes of free storage. So there is various instances you can choose from. Obviously, I'm afraid we're not eligible for free tier because 1 gigabyte room RAM is not going to be enough for us. So I'm going to keep that one as it is. It's just for showing you guys. Another important point, so we need to create a key pair. So what we're going to do is we're going to create a new key pair. We're just going to call this keys. We can leave all the default sections in here, so we just create a key pair. As you can see, the key pair is in our downloads. We need to create a security group here as well. So we need to select how we're going to allow SSH traffic. So at this point, we need to select our IP address. Just mind you guys, when you select this, obviously, depending whether you have a static IP address, your IP address might change every 3 to 7 days. So you might need to update those rules, and I'll showcase how to update once it goes, once you build your machine. Obviously, we need to update our storage account. So we can put there 40 gigabytes of RAM. And that's pretty much it. That's all set up. So we selected Debian 11 image. We named it. We created a key pair. We also created a security group to make sure that we can log into the SSH once the machine is up and running. So we're going to launch the instance. So we'll just take a few seconds once the instance successfully initiated. So as you can see, I've got one already running, which is Debian 11, and we have Debian, which is just pending start. So we'll just wait a few seconds once it's up and running. So there we go, it's up and running now. So now what we need to do is we need to connect to that instance. So how do we do that? We're going to run cmd, and I'm going to open a command prompt. So what we need to do now as well, we need to go to the directory where the keys has been saved. So our keys will be saved in the downloads directory. So we can just type in cd downloads. Oh, sorry, I misspelled it. cd downloads. There we go. So now what we can do is we can just select this instance, press connect. And as you can see, there is a code for us already written how to connect. So if we just copy that command, paste it here, and click enter, connection refused. So it's probably still starting up. So we're going to try in a few seconds again. There we go. It's up and ready. So we just need to type in yes, we want to connect. And there we go, we are connected. So now the main points what we need to do is, as we always, because we have a fresh install, we need to make sure we update all the libraries. So how we do that, we do sudo to make sure we run it as root, and then we do apt-get update to make sure all the libraries are updated. Once that's complete, we're going to do sudo apt-get, and then we need to make sure we install git. There we go. apt-get was still updating, that's why it wasn't allowing us to install Git. So we just downloading all the packages for the Git. So once Git is installed, then we can start running through installation procedure. So I'll just open this here, and what we need to do is we need to clone the repository first. So we're going to do clone this repository. As we can see, we have a progress here. It's about 50%. It'll take a few seconds to clone the repository. Okay, that's been complete. Now we need to make sure we are in the installer directory. So we just go to the installer directory, and then we need to make sure we run this install shell script. So all we need to do is, again, sudo paste and run the installation. This installation is going to take a little while, but there's going to be some user intervention where we need to select and set up the specific installation that we want to get. And I'm going to showcase here, there should be a section where it shows the installation you can choose. Because there's a few different selections that you can choose during installation, how you want to run this Honeypot. So as you can see, it's updating various listening ports. So it just asks, do we want to continue? Because T-ports might collide. So we put yes. And now this is the selection. So as I said before, we can create a T-port standalone with everything you need. So it's a standard installation. We can have a Hive, which has Elk and other tools. We can create a Hive sensor. So you can find more on the GitHub repository and find out. We can create one for industrial. So if you're working in sort of industrial control systems and want to track what kind of threat actors, you can also create one for specifically for Log4j. If you work with anything to do with medical securities, if you need to comply with things like HIPAA, so again, that's something you can build one with. Like for medical, you can build one as mini, same as standard, but it's more focused on Q honeypots, and you can create one as sensor. So we're just going to select one that's to build the standard. So we need to create a username now. So I'm just going to create something simple because I'm going to remove this afterwards, but I'm just going to create my first name, but you can guys put something quite unique. Make sure obviously something that you can remember. So username, yeah, and then we're going to create password for the user. Click OK. Make sure we retype the password and click OK. And then installation goes on its way. What you'll notice, guys, once the installation is complete, it will kick you out because it will change the SSH port on that machine. So we can just look through some of the files in here. So as you can see, it says about distribution, how we can build T-port with Hive, and Hive we can build one with Hive sensor. As I mentioned before, you know, if you're working with cloud and you want to go into sort of enterprise cloud engineering or cloud architecture, it's a good place to learn how to deploy all of this via Ansible or via Terraform. So there is sample codes where you just need to change specific values and deploy it. And you can see, I'll show you. So once you deployed, you have a few interfaces. So you have SSH and Cockpit that you can log in and see how all the pods are performing. And then we have a landing page where we have all the tools in here. So how Kibana dashboard looks like, how a tap map looks like. We have such tools also, such as CyberChef, where you can do all kinds of hashing and translation from, you know, if you want to sometimes convert something from base64 into hexadump or something like that. Elastic View is essentially, it's a good way to track how much memory your teapot is using. And Spiderfoot is something that you can do various scans to see how what information is there around your machine. So let's just see, it's still installing and unpackaging things. We'll just wait a few more seconds to see how long it's gonna take until the installation is complete. But as you can see, guys, it's pretty straightforward. All we need to do is just create a machine. We need to make sure we update all the packages once we connect to the machine. We also need to make sure we always install Git, because as you can see, the installation is made for Git, because we do git clone repository. So we do git clone, we go to the teapot ISO installer directory, and then we just follow the install shell script, and that's pretty much it. And we just wait until complete, and then I'll show you also what we need to do once it has completed, because once it's completed, obviously don't forget, guys, that we need to open up the firewall to make sure that, you know, threat actors can access this machine, because currently the only port that is open is 22, which is SSH, which that's how we connect it to this machine. So we'll need to update that as well. As you can see, it's installing all kinds of triggers, SSH packs, Python, tools, npm packages, Perl, and various databases. Generating RSA private keys. It's cloning the teapot into its directories as well. Take a few more minutes and it should be done. As you can see also, so when I explained earlier, there is a required ports which are operating. So obviously these are the three main key ports that we're going to use. So because we're going to essentially, this teapot is running a Nginx reverse proxy as a web server. So that's how we connect to the web interface. That's how we can connect to the SSH, and then we have a connection to the cockpit, which is essentially a web version of SSH, which showcases what kind of services, and then all these ports show which kind of honeypots are running on which particular ports. So you can see we have a snare, we had medport, log4port, we have the most famous, we have cowrie honeypot, Dioneer pods. So you're just completing the last layers and making sure the pod images are correct. Just verifying the checksums. As you can see, he's just checking Elasticsearch, Suricata images, the Kibana dashboard that we're gonna see in a second. As I told you guys before, so there is obviously different folders. So you have cloud deployments in here where you can have sample, Ansible and Terraform code. You have Docker images and how to deploy it through Docker, various pods. You have a YAML file. And as we can see, some of these have been updated not that long ago, so obviously it's keeping up to date. So there we go. As we can see, it clean up, rebooting, and we've been kicked out. So that means the installation has been complete. So now we need to complete the last two important parts. So we go back to instances. So we see our Debian instance is running. So we just go into the instance. We need to make sure we go to the security groups and we pick. So we need to make sure that we got the correct. So we got correct security group. This is the one. So what we need to do is we need to edit rules. We need to delete that rule that we just had, and we need to add the new rules. So we need to add the two important rules. So we're going to create a port that we can access this, as I mentioned before. So there is the three main ports, as you can see from here. We need to configure in here. So we need to add those three ports and add a connection to our IP. So this is the main one, because obviously this is the web interface. So I'm just going to put this here. I'm going to select my IP, and then we're going to add another rule. So essentially we need to make sure that this is accessible. So we're going to do 0 to, and then we're going to open 64,000 ports, and then we're going to select anywhere IP4. So that means essentially 0000/0, and we're going to save the rules, and there we go. So now if we go back to the instances, just to make sure that it's working, so how we can do is we can see Debian, and as we can see this is the public IP address. So what we're going to do is I'm going to open a new window, HTTPS, and then we're just gonna type in that address. So it's going to be 18.133.159.165.159.165. Just making sure it's correct. Yeah. And then we're gonna do a port 64297. As you can see, it's not a private connection, so we continue, and I'm just going to type in my username and my password, and there we go. We are in the teapot, and teapot is running. So we can see the attack map. We'll just take a few seconds to generate some traffic. So as you can see, there's 3 connection attempts. We also can go to Kibana. So these are all of the dashboards, but I'll showcase, I have one running so I can show some more data, but we can see also Elastic View. So again, we can type in the same username and we can type in the password. and we just connect, and then we can see all of the information about cluster, how many shards we have running. We can view the nodes, so you can see how much CPU is currently being used, how much RAM is running, how much heap in the memory is being used, how much disk space we already use. So as you can see, we already, through this installation, we used up 11.3 gigabytes, which is about 29%. We can see the shards, how many running, indices, we can do various search, and there we go. But let's explore one that I already built earlier. So let me just bring this here, and I'll bring an attack map that I had running before. So this one I started, I think, around 5 hours ago. So as you can see, there's currently around 1794 attacks in 5 hours, and it's currently running around 256 attacks hourly. So as you can see, based on the colors, so we can see the colors, which type of services they're trying to export and use against us. So, you know, red ones is FTP, you got orange ones SSH, you got IP addresses, and obviously with the flags where they're coming from, hits, where is the most hits. So as you can see, United States first, Netherlands, then United Kingdom, and obviously these are live sort of attacks that's happening currently, so on the map. Now if we go to Kibana dashboard, so the main point is here you have around, I think there's about 20 dashboards, but the main one is obviously Teapot. So it sort of summarizes all of the attacks that's happening. So as you can see, for example, here, out of the sort of 1700 attacks, 1000 of them are honey trap. You got cowrie attacks, denier, all these different honeypot attacks against us. You have, you know, a histogram to show. You have obviously unique IP addresses, map analysis. You got histogram by countries, by different honeypots. You have obviously also these attacker source IP reputation graphs. So you have known attacker, mass scanner. You have what kind of honeypots they're using, what kind of software these honeypots are using, attacks by country. You have attacks by country and IP address, what kind of Suricata alert category they're using, and then obviously, as I mentioned before, guys, so you have, these are the main usernames that they're trying to use and the main passwords. So if you buy something like Docker or you deploy Ansible or things like that, normally they have a default password, so you need to make sure that none of these usernames are used in your environment, and same as passwords. As you can see, there's top 10 Suricata alerts, top 10 CVEs that they're trying to exploit, attacker IP addresses, and then obviously the internet providers where they're coming from. So you can see there's Akamai, ChinaNet, there's Hong Kong one here, so there's loads of information here, but this is the main one. So if we want to go deeper into specific honeypot attacks, for example, so we have honey trap, you have a cowrie, so we can bring another dashboard to explore a bit more. So for example, we had Honeypot, we have different kind of, so there we go, we have a cowrie dashboard. So we can see and analyze deeper how cowrie attacks happening through maps, what kind of attacks, what kind of source IP addresses they're using. It just provides more information. As you can see, what protocols they're using from which countries, this lovely graph which showcases how it's all done, the IP addresses, IPv4 and IPv6 addresses, again same usernames, passwords. You can see command line input, what command line variables they're trying to run. You can see they're trying to get to busybox, system shell, and yeah, all of this information. What else we had from the dashboard? It's interesting to show you guys. Just trying to update it, see. Just to be aware, obviously, because these machines are running a lot of attacks onto them. So sometimes you just need to reboot the machine to make sure that it's still working. And that might be the case currently. Let's just see if connection comes back. Worst case scenario, we can just connect to the different TPOL. Yeah, we have a little delay because the attack map has not updated for 2 minutes. So let's just okay, let's just try and connect to this one. So let's connect to the just new one that I've just built and see how much information is in there. So I just showed you guys how the cowrie looks like. Let's see if there's anything in honey trap information. This one obviously just started running, so you already have, as you can see, you already have 33 attacks. Let's just look at the map, how many total attacks this new machine has already had. And let's just see if we go into the main T-port. So yeah, we had 33 attacks. All of them currently has been into honey trap. As you can see, these obviously username and password, it will take a couple of hours to generate enough traffic to get associated keywords for usernames and passwords. This is just a new obviously machine that just been launched. And as you can see, it's this live attacks start populating. So we got attacks now from Nigeria, United States, China. They come from all sorts of places, and as you can see, you can watch it live. So obviously you can see what kind of service they're trying to exploit, what kind of honeypot is running, and from where it's coming. So this is just an easy way for you guys to deploy honeypot, try all the different dashboards, collect different information, and see what kind of attacks are happening live in the wild currently. Hope you like the video, guys. Please like and subscribe, and let me know what other videos I should explore in the future. Thanks.